Assalamualaikum warahmatullahi wabarakatuh. We are from Group D in subject Vehicle Dynamic Assignment, which is Vehicle Tyre. So our group member consists of 5, which is Muhammad Sazmin bin Ahmad Firan, Xia Yu Jiang, Ketet T Changlong, Port Insem Wo Yuni, and lastly me, Insafan bin Muhammad Naisham. Okay, next. Okay, for introduction of our project, tyre are designed to support the weight of the vehicle, absorb road shock, transmit traction, torque and braking force to the road surface. And the tyre is very important for the vehicle to travel on the road. So in this literature review, we will discuss about the new design of flat-proof non-pneumatic tyre, and tyre made of 70% recycled material, mass of tyre, selection of suitable tyre for good handling, and tyre pressure remote monitoring system reducing the rubber waste. So this is our literature review. There are 5 titles. Okay, next. So then we go to the discussion part.
My name is Vincent. I will talk about the journal 1. My title is New Design of Flat-Proof Non-Pneumatic Tire. For the first methodology is investigate the effect of disease spot on the wheel performance. To investigate the characteristic of the district spot, it needs to use commercial finite elements, which is a solid wood. These experiments involve the change in spoken number and its effects on the radial stiffness at different angular positions. For each angular position between two consecutive spots, a radial force was applied. The deformations at the same point was recorded and the radial stiffness was computed. For the result, the increase of the numbers of spots flattened the stiffness variations curve and the decrease considerably the fluctuations amplitude towards the average value. The immediate result of that would be rides with smoother quality. The second methodology is continuous spoken design. The continuous stiffness design is not affected by angles of rotations of the tire because it does not consist of the disease spot components. The tire shall be divided into 3 portions. The outer shell with provided the tire rod's contact. The second is the intermediate shell with which provide the elasticity. The third is the initial shell which provide the tire rings contact. For the result, the tire design in open circles because it will more convenience for mounting and dismounting. Adding a curved geometry to the sidewall in order to create a flexible zone that could provide the same elasticity as in a conventional tires. The main advantage that made this type of tires has more suitable in terms for ride comfort.
For the material selections and testing of the non-pneumatic tires, for the choice of materials, the fibers reinforced polymers, which is FRP, has been chosen to manufacture the NP tires. This type of composite is easy to shape, has excellent damping properties with lightweight, and can be used in multitude of environments which having any particular concern in the unionization. To check the aspect stiffness of the design tire and to verify its matching with the previous experiment result collected from the convitations pneumatic tires. Finite elements simulation of the new non-pneumatic tires should be done by the SolidWorks software. Check the boundaries, conditions, and vertical deformation value. For the result, by keeping the same materials, the new tire design will have a specific thickness. The thinnest outer shell with 5 mm thickness in contact with the ground. The second is thin elastic shell of 2 mm thickness at the middle hollow channel. The thinnest initial shell of 5 mm thickness in contact with the rim. And the last methodology is lateral cut on the sidewall. In flattened tires have a throttle shape are characterized by non-developed surface with a double curvature that matches the structural stiffness than a regular flat shell. Deformation of the tire is confined more to the top of the tires. For the result, both stress allows both the stress and the deformations to reach the elastic part of the tires. The cut will introduce a break the integrities of the circles and to increase the resilience of the tires. For the final products was a non-pneumatic tire with mechanical properties very close to most of the commercial pneumatic tires. That's all for me. Thank you.
My name Muhammad Shazmin bin Ahmad Kiral. I will explain Journal 2. The title is Goodyear roll out one tire made of 70% recycled material and another 0% air in it. Okay, for methodology, first build tire from sustainable material. This year edition is not exception to the show evolution into an excellent platform for automotive related product. Reliving two goods that are both unique in their own way. One is composed of 70% suitable material, while the other does not require any air to work. Number two, a test program for an airless tire. Announce a test program for an airless tire. This will be tested by Starship Technology. Okay, for the result, the tire recyclable element will help the firm minimize its reliance and on a petroleum supply. Carbon black, which strengthens and extends the life of the tire compound, is traditionally made by burning petroleum. But Goodyear create carbon black from methane, carbon dioxide, and vegetable oil, reducing carbon emission in the production process. To keep the rubber flexible when temperature fluctuated, extra soybean oil from the conventional food and animal business was used. In contrast, silica is required to enhance grip and minimize fuse usage. Rice has as a byproduct of rice manufacturing that commonly end up in landfill was used by Goodyear to develop a novel kind of silica. Goodyear has also made tire cord by recycling polyester from plastic. Over 1,000 autonomous robots that deliver items are built and operated by the company. Michelin has previously developed an airless tire and tested it on Chevrolet boat in 2019. Okay, thank you. Next.
My name is Changlong. I will discuss about the Journal 3, Evaluation of Tire, Road Noise and Texture Interaction on Rubberized and Conventional Performance using CPS and Profiling Measurement. For the methodology, first we use the close proximity CPS method. It will evaluate tire noise close to its source. For example, the contact interface between tire and road surface by placing at least 2 microphones close to the tire. After that, we do the road texture measurement. A triangulation point profile sensor compared with the requirements reported in ISO 134732 was used. The setup is based on measurement system mounted on a self-powered vehicle, where the CPS equipment and the profilometer for texture measurement are deployed at once, thus ensuring perfect alignment of thickness and same measurement condition. For the noise and texture correlation, the correlation coefficient was evaluated separately for each copper and envelope texture and noise band for the reference and the rubberized surface. The results were used to evaluate difference between the two kinds of rock surface. Okay, next. For the analysis and results, correlation curves are shown in figure 2 and 3 are in accordance with previous study, with low frequency noise positively correlated with rock texture and a high frequency zone negatively correlated with rock texture. As it can be inferred by observing the figure, the influence of crown rubber in the midst of bitumen modified the correlation curve, extending the frequency negatively correlated with texture and reducing the positively correlated frequency band. This widening of the negatively correlated zone could represent a significant acoustical benefit of the usage of rubberized surface against the reference dense asphalt concrete surface. Low noise emission surface represent the best solution to mitigate noise for road with high and continuous traffic flows. Rubberized asphalts probably are the best choice in the modern concept of green and circular economy, since they use end-of-life tire to improve the property of road surface.
We go to the journal 4, which is the title is Selection of Suitable Track Pattern will give the best handling performance. So for the journal, they use the three-dimensional track pattern. Profile was obtained using a C-twist laser scanning machine, as shown in the diagram. Okay, the track profile data were then converted to parameter for quantification of the track impact mechanism and of the air pumping mechanism. So, for example, of the digitalized 3D profile is illustrated in the below figure. So, the measurement resolution is 0.5 mm in the length or width direction and below 0.01 mm in the height direction. So the step for the methodology is firstly a simple rectangular shape. Contact patch geometry is assumed. So for the second is the tire is assumed to rotate at 60 miles per hour. So the contact of the patch move along the tire circumference also at 60 miles per hour. So next, they're utilizing the 3D digitalized track profile. So the air volume in the track groove within the contact patch at each time is calculated for air volume versus time, as shown in the graph below. So then the air volume signal is differentiated with respect to time to yield the volume velocity trace. So finally, the air volume velocity spectrum is obtained by taking the Fourier transform. So next, we go to the analysis track pattern. So there are three track pattern that used in the vehicle. First of all, rib tracks. So for the rib track, the track pattern are in the form of a parallel circumferential groove. So the benefit of this pattern is good for lateral resistance. So it's directional stability and steering control. So the rib pattern is good for sustain for high speed vehicle due to less resistance to forwarding motion. So this track pattern usually used in paved road surface for bus or truck. So secondly, we go to the lug tracks. So this track pattern are in the form of groove perpendicular to the circumference of the tire. So for this track has excellent braking power. It also has very high rolling resistance, and so it the main reason that is not suitable for high speed. Usually this track pattern used on dirt roads for rear wheel of buses, industrial vehicle and dump truck. So for the third is rib lug track. For this track pattern, this is a combination of rib and lug tracks. So this tire track pattern give good braking and driving power. So usually for this track use both for path and dirt roads. Okay, next. So for the fourth is block thread. The pattern of this thread consists of independent block divided by circumferential and lateral groove. So this thread pattern give good steering control on snow, covered and wet road. So usually used in for wet and winter tire. So next we go to asymmetric threads. For this thread pattern, there are thread pattern on the inner side have more groove. Okay, so this thread pattern try to optimize opposing properties of dry grip and water dispersal. So this thread pattern is suitable for dry and wet condition. Usually, this thread pattern used in high performance and motorsport tires. Okay, lastly, it has directional thread. For this thread pattern, this pattern is characterized by lateral groove on both sides of the tire pointing in the same direction. So the benefit of this thread pattern is give good traction and braking properties, and also it has good stability on wet roads. So usually this thread pattern is used in high-speed passenger car tires. That's all.
Last journal, journal 5, the title is Tire Pressure Remote Monitoring System to reduce the rubber waste. So in this journal, there is 3 methodology used. The first one is continuous monitoring system design. So there's 6 components here. You can see this 6 component is used to design the monitoring system. So first, the TPMS sensor is installed inside the tire to measure the air pressure and temperature every 4 minutes. And the obtained values are sent wirelessly to the display in the driver's cabin using a mobile device with an Android system. So the Android system works in accordance with Java programming language, HTML5, and the notifications are obtained through the internet connection. And for the TPMS outdoor sensor, it is used to amplify the radio signal from the indoor sensor. So for Apple devices, push notifications are sent via Wi-Fi, Bluetooth, or internet networks like 3G, 4G, or LTE. So, and the last is the display identifies each sensor, analyzes the data, and shows the position, air pressure, and temperature of tires, and also giving a warning in the form of an alert when it detects a problem. For the second is experimental. There is 3 measurements here. The first one is stationary measurements. So tire pressure measurements were made each time when the tire came down to the home base, which means the tire is completely cooled down. For the second is in-use tire pressure and the temperature measurements. So the measurements were made by the sensors on average every 4 minutes, and the data was saved on a server and sent to an internet platform with the option of downloading the spreadsheet file. And for the last measurement is tread height measurements. So tread height measurements were made with a laser scanner after each vehicle descended to a home base. If the tread value was equal to or less than 4 mm for at least 2 tires, then it means that the tires was deepened. And for the last methodology is comparison of data without monitoring system and with monitoring system. So you can see from these 2 graphs, so it is comparison between the tread depth measurements. So with monitoring system, you can see the tread depth is lower than the tread depth of without monitoring system. So for the result, so the use of these pressure monitoring systems allows you to extend the distance that can be covered by the tire from about 200,000 kilometers to over 600,000 kilometers. So you can see from this graph. So for the orange color, it is without a monitoring system. It only can travel 200,000 kilometers. And if the vehicle is with monitoring system, it has 70% of wear reduction. So it can travel 600,000 kilometers. So this also means that instead of 215,000 tires, it is only about 71,700 tires may be used up. It also means that it has a possible reduction in the amount of worn tire by 143,300 tires. So the reduction of this generated rubber waste will amount to 71,650 tires on a national scale, which means over 2,000 tons less tire waste per year. So this data is based in Poland. So in conclusion, it can be concluded that the presented system allows to reduce the amount of waste and reduce the cost related to the purchase of further tires for the fleet. For the conclusions of this assignment, so in this literature review, we have gained a lot of knowledge about the vehicle tires. So there is many aspects of vehicle tires that we can learn in this assignment. So such as the noise caused by the tires, latest technology of manufacturing the tire, like non-pneumatic tire, and the selection of tire tread for better handling. And lastly is the solution of reduced rubber waste produced by worn tires. So that's all from us. Thank you for watching this video.